Having alternating series means that we have to introduce a couple different versions of convergence. We have absolute convergence and conditional convergence. Now, absolute convergence means that we take the sum of the absolute values of all of the terms. So in other words, every term is positive no matter what. And if we sum those and then it converges, then we say that that is converging absolutely. If, however, when we take the absolute value and we sum them and that diverges, but then we take the regular sum and that converges, then we say that that is converging conditionally. This only occurs with alternating series. So we'll make a little note, right? This bit, converging conditionally, is only for alternating series or series with mixed signs. Technically, they don't have to go plus, minus, plus, minus, plus, minus. They could go plus, plus, minus, minus, plus, plus, minus, minus, or some combination. So, series. So that conditional convergence can only be for alternating series. Note that if a series, it is possible, that a series could converge conditionally, but not absolutely. As a matter of fact, let's look at that right away. So we have a series here that we are very familiar with. So over on this side, we have, actually, let me do it this way. Over on this side, we have a sub k, right? That's an alternating series. But over on this side, we have the absolute value of a sub k. It's lost the minus, plus action, and all you're left with is the 1 over k. But this one on the left, that's the alternating harmonic series, which we have already proven it converges. It's 1 minus a half plus a third minus a fourth plus dot dot dot, right? It converges. And on this side, we have the harmonic series, which we've also already proven diverges. Because that's 1 plus a half plus a third plus a fourth. Interesting. So we have a series that when we take the absolute value, make it all positive. So when it's all positive, it diverges. But when it's alternating, it converges. Okay, so that means that this series right here, this one converges conditionally. It converges on the condition that it's alternating, right? That it has a mixed sign. Actually, I'll do it this way. Okay. Now, what about the other type? Well, let's see here. Oop. All right, so over here I have a sub k and an absolute value of a sub k. Oop. So this one on the right is always positive, and the one on the left has mixed signs, right? It's alternating. Okay, well, we've already proven that this one is a convergent alternating series, right? We proved with the alternating series test. So we proved, I believe in example 1a, but I could go find it. Yep, it's right here. Alternating series test, we proved it converged. Right there. So we proved in example 1a that this is an alternating, this is a convergent series. By the alternating series test. All right, now the one on the right, we know what that is. That's a power series. All right, so that's a p series. It's convergent because it's a p series with p equal to 2, which is greater than 1. Therefore, it is convergent. So it converges for an alternating series, but it also converges when we take the absolute value. Since it converges for the absolute value, that means that the series -1 to the k plus 1 over k squared converges absolutely. It converges whether or not it's alternating. Whereas this one only converged when it was alternating, but did not converge when it was all positive. This one converges when it's all positive and converges when it's alternating. Therefore, it's converging absolutely. Now keep in mind that a series may converge conditionally, like this, conditionally, on the condition that's alternating, but not absolutely. I know in the winter of 2020, there is actually a comment here that is incorrect. A series, if a series converges absolutely, it converges. So that second comment is not correct, and you can scratch it off in WN20. I will take it away for future. So the only comment you need to know is that if it is possible to do conditional convergence without absolute, if it does absolute, though, then it does converge conditionally as well. Well, it doesn't. Conditional means that it only converges if it's alternating. So absolute convergence implies convergence. Absolute convergence is a very powerful thing, which actually leads us to the next comment, right? If it converges absolutely, it converges, right? Straight up. It's not conditionally convergent, it's convergent. It's more powerful than that, right? So if it converges for the absolute values, then that converges. And similarly, well, not similarly, but alternatively, if the if the alternating values diverge, in other words, if the limit is not 0, then that means that the absolute value will diverge also. We already saw that when we had alternating series. Remember, the one without the absolute value is the alternating. So we had alternating series that were diverging. That means that the absolute value will diverge also. And just to clarify the top part, the term conditionally convergent, that term only applies to alternating series, and it only applies when they converge when they're alternating, but not when the terms are all positive. So conditionally convergent is kind of this special thing, and it's kind of a weak kind of convergence. It's not very strong. So absolute convergence, on the other hand, is quite strong, because when it absolutely converges, it converges. And similarly, when the alternating series diverges, then so does the original, or so does the all positive series. Okay, so let's read this over. The distinction between absolute and conditional convergence is only relevant, correct. So you only worry about these terms if it's an alternating series. If it's not an alternating series, then you don't really care, right? So these terms are only relevant for terms with mixed, or series with mixed signs. If a series of positive terms converges, it converges absolutely, because conditional convergence does not apply. Right, exactly. So these terms right here are only really useful for series with mixed signs. However, I mean, you could think of it, any any series that has all positive terms, you can think of it as being absolutely convergent and convergent, because they're the same thing, because it's all positive in the first place, right? So convergent series is up here. Absolutely and conditionally convergent are things for mixed signs. So mixed signs go down here. So these two terms are things we use with mixed signs. If it's not mixed signs, then you wouldn't bother with absolute and conditional. You just say it's convergent or divergent and walk away, right? So these two terms generally are only used for series that are either alternating or with some kind of mixture of signs, positive and negative. And then they're just making the comment here that, well, if it's positive and everything's positive anyway, then if it converges absolutely, because everything was positive, and so what difference does it make, right? Conditional convergence does not apply to something that's all positive anyway. Right? So if you want to think of an all positive one as being both convergent and absolutely convergent, knock yourself out, but it doesn't really make any difference. To test for absolute convergence, right, we test the series with the absolute value. And we'll practice that in our next video.